Hello girls, I hope you're staying safe at home. To continue with the water chapter, we come to the last section, which is soft and hard water. Now you'll be surprised to know that there are two types of water, soft and hard water. Now when is water called soft? If it readily forms lather with soap, when you take soap and when you use it on your hands and wash, lots of lather will be formed. So what type of water is that? That is soft water. Okay, pure water or water containing sodium salts, remember, easily gives lather with soap. Either the water is pure or it contains sodium salt. So this water is known as soft water and is suitable for use. Examples of soft water are distilled water and rainwater. And just the opposite, when is water said to be hard? When it does not readily form lather with soap. Okay, so what are the causes of hardness of water? There are water of some springs, wells, and rivers which contain dissolved mineral matter. You know, water is a universal solvent, so different types of minerals are dissolved in it. So if this happens to be hydrogen carbonate, sulfates or chlorides of calcium and magnesium, the water gets hard. That means in the water, if calcium hydrogen carbonate or calcium sulfate or calcium chloride is dissolved, then the water is hard water. Or it might also be magnesium hydrogen carbonate, magnesium sulfate, or magnesium chloride that is dissolved in the water. Okay, so hardness in water is due to the presence of bicarbonates, chlorides, or sulfates of either calcium or magnesium, either magnesium bicarbonate, magnesium chloride, or magnesium sulfate, or it may be calcium bicarbonate, calcium chloride, or calcium sulfate. Then the water is said to be hard and it will not form lather easily with soap. Now, how does this happen? Now, when water flows over beds of limestone or dolomite, limestone is calcium carbonate, dolomite is magnesium carbonate. So, water is flowing over lots of limestone or dolomite. What happens? Carbon dioxide slowly converts or turns some of these soluble calcium and magnesium bicarbonates. Okay, so they are dissolved and it gets mixed up with the water and makes the water hard. So you can see insoluble calcium carbonate, that is limestone, with carbon dioxide in the flowing water will turn into calcium bicarbonate, which is soluble and it dissolves in the passing water. Similarly, dolomite or magnesium carbonate with carbon dioxide that is present in the flowing water, it will turn into magnesium bicarbonate, which is again soluble in the water. So hence what happens? The flowing water becomes hard. So the formation of stalactites and stalagmites in caves is due to the same reason. Now there are certain limestone caves that has lots of limestone. Now you know what is limestone. It is calcium carbonate. So you will see conical pillar like objects, some hanging from the roof of the caves and some rising from their floor. Okay, so these are formed by the water dropping from the cracks in the rocks, which contains dissolved calcium hydrogen carbonate. So when the pressure is released and the cave inside is warm, what happens? This converts or reconverts the hydrogen carbonate, which is dissolved in the water, to calcium carbonate, which is insoluble. It is solid, stone like. Okay, so the calcium bicarbonate turns into calcium carbonate, which is insoluble, solid, stone like, and carbon dioxide and water. Okay, so the calcium carbonate little by little gets deposited both on the floor as well as the roof of the cave. So the conical pillar which grow downwards from the roof is known as stalactite. You can see here growing downward, all these are all stalactites. Okay, and the one which grows upward from the floor of the cave is known as stalagmite. There from the floor, can you see? In the upward direction, it is growing in the upward direction, that is known as stalagmite. And sometimes here in this case here, can you see, it has met, the stalactite coming from the top and the stalagmite coming from the bottom has met, and it has formed a pillar like structure. So in a year some grow less than even a centimeter, but some as tall as 100 centimeter, that is 1 meter. So it depends of how much calcium carbonate is formed. Okay, now if water flows over beds of gypsum, what is gypsum? Calcium sulfate dihydrate. That means having two molecules of water. A little bit of gypsum gets dissolved in the water and it also makes it hard. That is sulfate. Okay. Now there are two types of hardness, temporary and permanent hardness. Now water that contains only hydrogen carbonates of calcium, that is calcium hydrogen carbonate, CaHCO32, or magnesium hydrogen carbonate, MgHCO32, then that water is known as temporary hard water. Now, why is it called temporary hard water? Because we can remove the hardness by just boiling it. So, what happens when we boil water that contains calcium bicarbonate or magnesium bicarbonate? Okay, calcium carbonate, magnesium carbonate, down arrow means it forms a precipitate. It comes out as solid, and water and carbon dioxide gas will be given out. So this water which is formed is soft water because it will no longer contain the substances which makes it hard. Now the calcium ions and magnesium ions are thus removed from the water by the formation of insoluble calcium carbonate and magnesium carbonate, which on filtration can be removed, and then the water will become soft. Now, water containing sulfates and chloride of magnesium and calcium are called permanent hard water because it cannot be removed by boiling. That is magnesium sulfate or magnesium chloride or calcium sulfate and calcium chloride. If it is dissolved in the water, then it is permanent hard water and we cannot remove it by boiling. Now, remember children, the removing of temporary hardness of water by boiling is not a practical method. It is very costly and it is very, very slow. Now, advantages of hard water. Hard water containing some dissolved salts have certain advantages. First is soft water free from dissolved salts has a very flat taste. It is the presence of salts in hard water which makes it tasty, okay, some sort of a sweet taste. So hard water therefore is used in the preparation of beverages and wines to give it taste. Calcium and magnesium salts present in small amounts in hard water are used, or it is important for the growth of our bones and teeth. Okay, calcium, you know, it is important for our bones and teeth. Now, hard water checks the poisoning of water by lead pipes, that is pipes which is made up of lead. When these pipes are used for carrying water, some lead salts dissolve in the water to make it poisonous, because lead is poisonous. Okay, so calcium sulfate which is present in the hard water, it forms insoluble lead sulfate in the form of a layer inside the lead pipe. So if this is the pipe, okay, you will see the lead will deposit here inside the pipe because it is a solid, okay, solid lead sulfate. It will stick on the walls of the pipe. So that way what will happen? Lead will not move along with the water. Now, next is disadvantage of hard water. Now, hard water is not suitable for producing steam. You know, steam means water vapor. Okay. Now, steam is made in boilers which are made up of a number of narrow copper tubes. Okay, there. This way, copper tubes are there inside. You can see these copper tubes are there inside all around here. Okay, now as the cold water enters these tubes, this entire tube, when cold water enters, it is immediately changed into, it is heated. This copper tube is heated, and immediately as soon as water, cold water touches this, it will turn into steam. Okay, while the dissolved solids incapable of changing into vapor, it is only water which changes into vapor, but the dissolved salts or solids will not be able to change into vapor. So it starts getting deposited on the inner walls of the tubes. So on the inner walls of the tubes it will get deposited, And this goes on and on until the bore. Here you can see how it has been deposited. So ultimately what will happen, the bores or the pore of the tube becomes narrower and narrower, and what will happen, less and less water can flow through the tubes as at one time, and very less steam is produced. Okay, now, when the bore of the tube becomes very narrow with lots of deposition of the insoluble salts, the pressure of the steam increases so much that sometimes what happens, the boiler itself, it bursts. Not only that, the boiler scale formed inside the tube, that is the solid which is deposited on the copper tubing, is a very bad conductor of heat and allows only a part of the outside heat to go in and convert the water into steam. So what happens? The efficiency, the working power of the boiler is reduced, okay, and there is wastage of fuel. Now, to minimize this loss, the boiler scale must be removed from time to time. It must be scraped off. Okay, it must be removed by using a boiler compound, or else water is first softened and then used. And for this, both cost money. For softening the water and then using, lots of money is required. Or when we use a boiler compound to minimize, to remove the boiler scale, that time also lots of money is required. Okay. Now, the furring of tea kettle is also caused by the sediment formed on its wall from boiling hard water. If you continuously boil hard water inside a tea kettle, a solid layer will be formed on its inner walls. Okay, so it is known as furring of tea kettle. The fur is nothing but carbonates of calcium and magnesium. Okay, now hard water, remember children, also spoils taps, washing machines, and even geysers. Now, hard water is also unfit for washing purposes. Now, for washing purposes, what do we use? We use soap. Now, soap is actually a chemical compound. Okay, it is a sodium salt of stearic acid, okay, which is an organic acid. This is the formula C7H35COOH, and has the formula C17H35COONA. This is known as sodium stearate. Okay, and it is represented as NaSt. Okay, St means stearate. Now, if the water is hard, if we are using hard water, the calcium and magnesium ions of the water, you know, in hard water calcium and magnesium ions are present, it is dissolved there. Okay, it will combine with the negative ions of the soap to form a slimy, slippery precipitate of insoluble calcium and magnesium. Okay, and this is known as soap curd or scum. Here you can see from the soap we have sodium stearate and calcium bicarbonate of hard water. It forms soap curd given by it is calcium stearate and sodium bicarbonate is formed. So this, what will this soap curd do? It will not make the clothes clean. Okay, so the formation of soap curd will go on as long as there are calcium and magnesium ions present in the hard water. Okay, so till then no soap lather will be formed, no lather of the soap will be formed, and cleaning the cloth or the body will not be possible. So these precipitates are very difficult to wash out from the fabrics as they are insoluble in water. And it is very difficult to wash out the precipitates so formed from the clothes because they are insoluble in water. Okay, and sometimes if iron is present in the salt, it will form reddish colored spots on the clothes. And you know, sometimes these iron salts, it is present in the water because water is a universal solvent. And of course, nowadays the difficulty has been solved by using synthetic detergents like Surf. You've heard of Surf, Det. Okay, they are used in place of soap at homes, domestic and laundry work, that is for washing clothes. And these are, how are these made? They are made by sulfonating some higher alkenes. Now, alkanes, you'll be learning in the part 2 of this book. They are known as organic compounds. So they are mixed with sulfuric acid, and then it is changed into sodium salts by using caustic soda. Okay, and these sodium salts are then known as detergents. Okay, now detergents are more soluble in water than soap, and are not affected by the hardness of water, as their calcium and magnesium salts are soluble in water, so they do not form the scur or the scum. Okay, and detergents are also known as soapless. Okay, children, before I tell you how soaps and detergents clean, your assignment for this week is to write down how hard water is formed when water flows over dolomite and limestone, and also how stalactites and stalagmites are formed. And as usual, you'll submit it day after tomorrow. So let's see how soaps and detergents clean. Okay, cleansing action of soaps and detergents. Now, when soap or detergent is put in water, it dissolves. So what happens? The molecules gather together in a cluster. Okay, it forms a group, and this cluster is known as micelles. And how do they stick together? Their tails stick inwards. Okay, like this, like this. The tail is inwards and their head is outward. This tail is made up of a hydrocarbon. Okay, hydrocarbon means made up of hydrogen and carbon. You don't know how many molecules of hydrogen and how many molecules of carbon is there. So when it cleans, the hydrocarbon tail attaches itself to the oily dirt. So if dirt is here in the middle, the tail is sticking to the oily dirt. Now when we stir the water, the oily dirt, what happens? It lifts off from the dirty surface, okay, and then it breaks up into tiny fragments or tiny pieces. So when it breaks up into tiny pieces, there are other tails. It will come and stick to these fragments or to these oil. So now what will happen? The solution will contain small globules of oil surrounded by detergent molecules. So the head is negatively charged. The head is negatively charged. Okay, so which is present in the water prevent the small globules from coming together. So it will not, the globules will not come together because the head is negatively charged, and so it will not come together to form a group. So the oily dirt is removed from the object. Okay, now moving on to removal of temporary hardness. You know, we already did, it is by boiling. Carbon dioxide is driven off, and the soluble hydrogen carbonates is turned into insoluble carbonates. So in the water there won't be any hydrogen carbonates left. So if there is no hydrogen carbonate, the water will not be hard. So when you boil water, we've already done that before also, calcium carbonate, which will settle down as precipitate solid, water will remain behind, and carbon dioxide will be driven off from the hard water. So what happens? Calcium carbonate, or if it is magnesium hydrogen carbonate, then magnesium carbonate will precipitate out. Precipitate out means it will become solid and the water will turn soft and carbon dioxide goes off as a gas. Now of course, as I've already told you, it is not practical when lots of water is concerned. It is not possible to boil lots and lots of water. Now next is by addition of lime, and this process, remember children, is known as Clark's process. Okay, so a more practical method, okay, that is to add a little bit of slaked lime. You know, slaked lime is calcium hydroxides. So when you add slaked lime to calcium bicarbonate, a reaction will take place, as you can see in this equation. Children, please remember these equations are very, very important. So similarly, calcium carbonate will come out as a precipitate and soft water will be left behind. Similarly, magnesium bicarbonate, which causes hardness in water, when calcium hydroxide or slaked lime is added to it, magnesium carbonate and calcium carbonate will precipitate out, leaving behind soft water. Okay, so how is this done? Clark's process. Lime is first mixed thoroughly with water in a big tank, okay, and then it is led to another tank containing hard water. First, lime is mixed with water in one tank, and then that is taken to another tank which contains the hard water. And then there are revolving paddles. Okay, it is going round and round, paddles are there, which mixes the two solutions. Now, most of the calcium carbonate settles down because it is a solid. Okay, and if there is any solid left over, it is removed by a filter. So this process is known as Clark's process. Okay, next is by adding washing soda. Now when washing soda or soda ash, which is anhydrous sodium carbonate. Anhydrous means it does not have any water of crystallization. Okay, when it is added to hard water, the corresponding again insoluble carbonates, whether it is calcium carbonate or magnesium carbonate, settle down and it can be removed by filtration. So here you can see washing soda, okay, that is sodium carbonate, is added to hard water containing calcium hydrogen carbonate or magnesium hydrogen carbonate. The solid calcium carbonate or the solid magnesium carbonate will settle down as a solid or a precipitate, and sodium bicarbonate is left in the water, which will make the water soft. This is how temporary hardness is removed. Okay, next is removal of permanent hardness. Okay, if the water is hard permanently, what is used? Soda ash is used. You know what soda ash is? Sodium carbonate. Okay, so the reaction takes place. Calcium sulfate causes permanent hardness. So when soda ash or sodium carbonate is used, calcium carbonate settles down. Okay, it is not harmful to boilers or any clothes, and sodium sulfate is left behind, which does not cause hardness in water, permanent hardness in water. Similarly, if calcium chloride is dissolved, then that water is permanently hard. So to that again, when you add sodium carbonate, calcium carbonate will settle down and sodium chloride will be left behind, so the water will become soft. Now supposing instead of calcium sulfate, calcium chloride, magnesium sulfate is present in the water, lime has to be used also apart from soda ash, because magnesium carbonate is not fully taken out. The water will still be hard. So you can see in the reaction, magnesium sulfate is there in the hard water, and you add sodium carbonate, you have to add slick lime also, that is calcium hydroxide. So then you will have the solid magnesium hydroxide and calcium hydroxide settle down, and only sodium sulfate will be left behind, which does not cause water to be hard. So this method which I just mentioned is used only for domestic purposes, only when little amount of water have to be treated. Okay, we cannot use these methods in large amount of water. Now if hardness is both temporary as well as permanent, so in this case what happens when large amounts of water are to be converted into soft water, a process which is known as permuted process is used. Now what is permuted? It is artificial zeolite. Now actually when we talk about a chemical, it is actually hydrated containing some amount of water of crystallization, sodium aluminium orthosilicate. Okay, so this is the formula. It is a big formula. You can see Na2 Al2 Si2 O8.xH2O. X means we do not know how many molecules of water of crystallization is attached to it. Okay, so to make it easier, the formula Na2P is given. Okay, so here what happens, you can see this is a tall cylinder here, is filled with lumps of permuted. So you can see here permuted is added here. Now when hard water comes in here, when it comes in containing calcium and magnesium ions, you can see it goes through the permuted. Okay, it goes through the permuted, and exchange of ions take place. So the sodium permuted is changed into calcium and magnesium permuted. Sodium, which is causing the hardness, okay, and with the removal of calcium and magnesium ions, the water becomes soft. So what comes out from here? Soft water comes out. So when no longer active, the permuted is regenerated by putting in a concentrated solution of brine. Brine, you know, it's salty water over it, and removing the calcium chloride formed by repeated washing. So here sodium chloride is added, that is brine water, and again it is renewed. Now remember children, zeolite is a naturally formed mineral. It is found naturally on the surface of the earth, okay, especially in large deposits of volcanic tuff. They can easily be dried, and it can be used as an ion exchange in the permuted process. Now, softening hard water using eye exchange resins. Now, for laundries, when you're washing clothes, and boilers, that is when you are, warming water, water softened by the permuted process is quite satisfactory. So we can use this water which is made soft by permuted process. But for scientific purposes, even the presence of positive sodium ion and negative bicarbonate, the positive is always a metal and negative is always a non-metal, okay? Sulfate ions is not desirable, it is not required. So to remove these ions, water is passed through synthetically prepared cation, that is a positive ion and a negative ion exchange resin one by one. So the sodium ion in this case, okay, is replaced by hydrogen ions, and bicarbonate ions and sulfate ions are replaced by hydroxyl ions, and then the water gets completely deionized, means there will be no more ions present in the water. Okay, so children, with this we come to the end of this chapter. I will take a test very soon. I will let you know when. Till then, children, stay safe. God bless you.